Okay, so far I've shown you how to implement some simple classes. So we've got a counter class, a point2 class, and a stopwatch class. In assignment 3, what are you doing in assignment 3? Someone remind me what you're doing in assignment 3. Ah, you're implementing a class of some kind in assignment 3. I don't remember what it is you're doing. There's a way to describe these diagrams. There's a way to describe your classes without actually showing people your source code. And so there's a notation called a UML class diagram. So we've seen this briefly when I showed you interfaces. I'm going to talk a little bit more about it now. There's a language called the Unified Modeling Language, or UML. So it's a language that's used to describe object-oriented software systems. It's a visual modeling language. So basically, it's a language whose elements are pictures. And that's a picture of the UML modeling of UML using UML. Right? So you can see that at the top of this hierarchy here, right, is something called the diagram. So all UML diagrams are diagrams. Right? You can have a behavior diagram, so that describes how your program behaves or how elements of your program behaves. And then you can have a structure diagram, so that describes the structure of your program or elements of your program. The only thing we're really interested in is this thing here, the class diagram. And you can see there's lots and lots of other diagrams that can be used. You'll learn more about these as you go through your computing science undergraduate career. You'll encounter more of these diagrams. For this course, we're only interested in this one. So the UML class diagram describes the structure of a class, and that's it. So it doesn't describe how the class interacts with other classes, but it does describe how your class might be related to other classes. So typically, so a class diagram must include the name of the class, and then depending on the context in which you're using the diagram for, you can show extra information. So you can show the fields of the class, and you can show the methods of the class and the constructors. So UML is a language that's not designed specifically for Java. It's intended for all object-oriented programming languages. So UML doesn't use Java-specific terms. It uses more generic terms. For the fields, UML refers to, for Java fields, UML would call those attributes. And for Java methods, UML would call those operations. So that's the simplest UML class diagram that you could have. Right, so it's just a box. Inside the box is the name of the class. And that, surprisingly, the font actually matters in these diagrams. Because this is a visual modeling language, the style of the font is often used to indicate some information. For a class, it should be in a normal font, and it should be centered on the box. Now, again, depending on the context, you can show extra information in your class diagram. So for example, you can show the fields of your class. Right? So the way you do it is you take your original box and you just extend it. So you add an extra box underneath it, and then your fields go in underneath. The way that the fields are written are the access modifier, followed by the name of the field, followed by a colon, followed by the type of the field. And everything is supposed to be left justified in this box. Your access modifiers are as follows. Right? So you can have a private access modifier in a field. You can have a public access modifier. And then we have package private and protected right there. Right? So all our fields in point 2 are private. Oh, wait, sorry. I missed this one. These are double and double. And again, depending on the context that you're using the diagram in, you can now show the methods and constructors. So they are shown in a similar way. You draw an extra box underneath the fields. Each method or constructor can have an access modifier. It has a name, it has a parameter list, and then it's followed by the return type. And so this is easier to see in an example. Right, so there's our point 2 class with all of the methods that we have so far in the class, all the methods and constructors. So all of our methods are currently public. Right? We have a constructor, the no argument constructor here. We've got the constructor that takes in 2 parameters, x and y. Right? So you write the parameter name followed by a colon followed by the type. Right? So again, it's not Java specific. It's in some generic. It's for any object-oriented programming language. We've got our two methods, x and y, so these are our accessor methods, right? So x returns the x coordinate of the point, y returns the y coordinate of the point. Right? There are our two mutator methods that change the point. There's our third one that changes both coordinates of the point, and there's toString. Right? So it's just a compact way to show the structure of a class. Now, if you have multiple classes in your program, you can show them all on the same diagram. And later on, you're going to see examples of when we make a class and it's related to some other class somehow. So for example, we'll be making objects that contain other objects. And you can draw a UML class diagram that shows that relationship visually. If your class implements an interface, you can indicate that on your diagram. So you use what's called the lollipop notation. And all you do is you take a solid line, you draw a solid line to the box and a little round circle, and then the name of the interface that the class implements. So this diagram says that ArrayList implements the list interface. This diagram here says treeSet implements the sorted set interface. It doesn't matter where this box, where this line is drawn. You can draw it off the corner, you can draw it off the top or the bottom, left or right. It doesn't matter. Right? It just depends on where you have room on your diagram. If a class implements multiple interfaces, you can show each individual interface. Right? So for, I guess, treeSet, you could draw another little stick and a round circle and then put in collection to indicate that it also implements the collection interface. All right, so there's the quick introduction to a UML class diagram. Occasionally, you'll see these in the lecture. And that gives you a quick overview of the features of the class, right, without actually having to show you source code. This is much more compact. Later on, we'll see more complicated examples where classes are related to other classes. Okay, so the next topic I want to talk about is testing, which we don't really, I think you might have done some in 121 if you took it last term. So testing, you should have been told, well, it's how you check your code to see if it actually works the way you expect it to. Right? So in modern software development, it's a vital part of the development process. The goal of testing is to find errors in your code. Okay? So there's this gentleman named Edgar Dijkstra, who is many things, but among the things he is, he's also a computer scientist. So he has this quote here that says, program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. Right? So in other words, when you test your program, you're looking for mistakes. You're not actually trying to show that it's correct. Right? Hopefully you find no mistakes, in which case you may be more or less confident that your program is correct, but you don't know for sure. The only way to show for sure, to prove that your program is correct is to somehow describe your program mathematically and then prove that your mathematical description of your program produces the expected mathematical output. So there's a whole field of research called formal methods that does exactly that. I think I mentioned that when we talked about preconditions and postconditions. Right. Okay, so the way you'd probably test your code before you took CISC121, I guess, is that you would just write a method somewhere, or you'd write a program and you'd try calling your methods, right? So I guess in assignments 1 and 2, you have one or more main methods. Inside the main methods, they call some of the methods or constructors in your class, and then you looked at the output to see if it produced the correct output. Right? I guess with assignment 2, you could have run the final program and you would have gotten a visual depiction of whether or not your program was running correctly. So when you test with the main method, there are some pretty serious disadvantages. Number one, it's totally inappropriate when you're testing large pieces of software. Right? So the problem is that someone has to look at the output that your program is producing to determine whether or not one or more of the tests have passed or failed. Right? Now, imagine if you're testing a program that's made up of thousands of classes. Right? Each one of those classes may have dozens of methods. Right? So you're looking at tens of thousands or even hundreds of thousands of tests that are running. Right? And no one's going to look at the output of 10,000 tests to see which ones failed or passed. Right? For small programs, though, testing with the main method is often effective. right? And that's why it's often done in an academic setting. It's because in a first-year programming course, you typically don't make very large programs. Another problem is all of your tests are in one big method, right? Unless you break your main method down into several other methods. Right? If you put all your tests in one method, then it becomes very hard to pick and choose which methods you want to run. Right? So for example, suppose you know that 20 of your 21 methods are running correctly, and there's one that's causing you problems. Right? Every time you run the main method, you're testing those other 20 methods that you know are correct, right? Just to see the result of the 21st method. It would be nice if you can pick and choose which methods need to run. Right? If you're testing many classes at once, it would be nice to pick which classes you want to test. Furthermore, you can't run tests independently from one another, right? Either all the tests run or none of them run. And that's also a problem. Right? Okay, so you can use what's called a unit testing framework. I don't know, you probably used PyTest, I'm guessing, in 121. In this course, we use something called JUnit. So if you click that link there, you can get a little quick introduction to JUnit. So JUnit's what's called a unit test framework. And a framework is just a semi-complete application. A framework provides the reusable common structure to share among applications. So all that means is that a framework provides you the skeleton of an application, but it doesn't provide you the full application. Right? When you use a framework, you write some extra code that uses the framework code to produce a complete application. So JUnit is a unit test framework. So what that means is that you can use the framework, you write some tests, and then JUnit knows how to run the tests, it knows how to report the tests, and other things. Right? It gives you a bunch of methods that support you writing tests, and so on and so on and so forth. So what's a unit test? So a unit test examines the behavior of what's called a distinct unit of work. Right? So distinct units, that means you're trying to test one thing. Right? And typically you're trying to test the smallest thing that you can run independently of anything else. So in a Java program, that means your distinct unit of work is often a method or a constructor. Right? It doesn't have to be, but that's often what you end up testing. So a unit of work is supposed to be a task that's not directly dependent on the completion of another task. Right? And so what that's trying to say is you're supposed to be able to test a method without having to call some other method, for example. Right? So in other words, you should be able to write a test for each one of your methods independently, and you can run each test independent of every other test. It's not always possible, but that's the goal. Okay, so remember, I guess 3 weeks ago, or roughly, maybe a little bit more, we had this funny implementation of max2. Right? So max2 finds the maximum value of A and B. Right? And it's a very strange implementation. Right? The reason it's here, though, is because we can test it. Right? And at this point in time, you should know why this method is incorrect. Right? So the problem is this method runs into overflow. Right? There's a sum here with 2 ints, there's a difference here with 2 ints, and then there's another sum here that also involves ints. Right? And so you know that any one of these operations might overflow. If one of the operations overflow, this method fails. But we can now write a test to show that this does in fact fail. Okay, so somewhere I've got a little Eclipse class, or sorry, a Java class in Eclipse called testing. It's got our max2 method in it. I would like to write a unit test using JUnit to test this method. Actually, I'm going to write several tests. So let's see how this works. So there's our testing class down here. So I want to write a JUnit test, and so JUnit is incorporated directly into Eclipse. If you right-click on the class you want to test, you can go to New, and then JUnit test case. Right there. Right, and that'll pop up that window there. In this course, we're using JUnit 4. There is a JUnit 5, but JUnit 5 uses a lot of features of the Java language that we don't teach in this course. So it's very hard for students in this course to use JUnit 5. So we're going to use JUnit 4. So just make sure you click New JUnit 4 test case. Otherwise, you end up with JUnit 5, and then everything doesn't work. You can pick the name of your class. So we're going to put all of our test methods into a separate class or classes. I guess the test wizard suggests a class name, so it's calling it testing test. So it's just your class name followed by test. You can change that if you want to. If you click next, it then asks you which methods or which classes and methods would you like to test. Right? So you can if you want to, you don't have to. You can just click that class and it'll automatically check you're going to test the max2 method. And then you click finish. It's going to ask you, do you want to put JUnit4 on the build path? You want to say yes. So perform the following actions. Click OK. And when it does that, it automatically creates the test class for you. It imports some basic stuff from JUnit, and then it writes an empty test method for you. So the way JUnit works is that all of the tests that it will try to run have this annotation @test on it. Right? So that indicates that the next method, or the following method, is a test method. If you leave the @test off, JUnit won't run that method as a test. Okay, so you create your test, right? You give it a name. Eclipse defaults to camel case here. My preference is to write it in a different way. And you might choose to do this too. You don't have to. You can use the default if you like. I actually prefer seeing the actual name of the method that's being tested, so I insert an underscore here instead of using camel case. It doesn't matter if you do this or not. I just think this is slightly easier to read. It's also useful to number your tests because you can run them alphabetically if you want to. And so that lets you run your test in a specific order. All right, so I'm going to save this, right? And now you can run this class, even though there's no main method, right? So you can run the class because we're using the JUnit framework, and JUnit understands how to run a class that contains a bunch of test methods in it. So if you click the little run button up here, JUnit starts up, runs the class that's under test, and reports the test results over here. Right? So a little panel opens up over here called JUnit, and you can see the result of your test. Right? You want to see a green bar up here. Right? If you see a red bar up here, then something's gone wrong. So it tells you that it's run 1 of 1 tests. Right? One of the tests that ran produced no errors, but it failed. Right? And that's also indicated by the little blue X that's here. Right? So a blue X indicates a test that has failed. So the test is actually run. Right? So the code inside the test method has run to completion, but the result that it produced was not the one that was expected. If you look down here, it tells you some more information about why the test failed. Right? So this one says it failed because it's not yet implemented, which makes sense. Right? So the method called fail that comes from JUnit, it comes from the assert class. So that method fail is the JUnit method that indicates a test should always fail if it encounters that line. Right? So we're going to get rid of that because we actually want to write a test. Okay, so when you make a test, what do you need to do? Right? So you're going to run a method. So that means you have to choose whatever inputs the method requires. Right? So you're going to pick some arguments to pass to the method. So for max2, we're going to pick 2 values to call max2 with. Right? You're then going to determine what is the expected return value when you call the method with the arguments you chose in this step here. Right? So if I call max2 with the values 2 and 5, I expect the answer to be 5. Now, some methods don't return a value, right? But they do something else. Right? So in those cases, you have to determine what is the something else that the method does, and how are you going to test what that method just did. Right? So we'll look at examples of those in a later lecture. So for now, we're just testing a method that returns a value. Okay, so a test case is the specific arguments that you're going to pass to the method, right? And it's the expected return value, if any, and the expected results when the method is called with the specified arguments. Right? So to run a test, all you do is call the method with your test case arguments, right? Record the return value of the method, test if the actual return value equals the expected return value. Right? So it's pretty straightforward, right? Define what your inputs are, define what your expected answer is, run the method, compare the result of the method to the expected answer. Okay, so we're going to call max2, so let's pick 2 values to run max2 with. Right? So int A, we're going to use, it doesn't matter, we'll just pick 0. Int B, we'll use 5. Right? What's my expected answer? So my expected answer is B in this case. Right? So that sets up my test case. Now I run the method with the inputs, recording the result. Right? So normally I call this, so the result I'm going to call got, or actual, whatever you want to call it. Run the method. It's testing, right? Testing max2 with A and B. Right? And so now I want to compare the expected result with the result that testing actually returned. Right? And now JUnit's got a bunch of methods that let you compare the two results automatically. Right? So the one we're going to use most often in the course is called assert equals. So assert equals, the full name of this method is actually org.junit.assert equals. So you're going to call this passing with the, so assert the expected value equals the value that was returned by the method. Right? So it's always, right, in assert equals, the expected result always comes first. Right? If you switch the order of got and expected, then your error messages are all wrong. It'll tell you that the expected value was the answer that you actually got, and the method that you actually got was the expected value. And so that makes your tests very confusing. Right? So always write it that way. Once you've actually checked the expected and return value, you're done writing your test case. Right? So what assert equals does is it tests is expected equal to got. Right? If expected and got are references, it uses dot equals. If expected and got are primitive types, it uses equals equals. Right? If the two values are equal, then the method, then nothing happens, and the test passes. Right? If they're different, or if they're not equal, then the test automatically fails, and you get some sort of message over here that indicates that the test failed. Right? So save everything, run it again, let's see what we get. Okay, so that's good. So that's what you want to see when you run your test case. You want to see a big green bar, right? You want to see no failures, no errors. Right? If you expand, if you click on that little arrow, and I don't know why they made it so hard to click on. There we go. Right? You can actually see the tests that ran. Right? And that tells you that test 1 max 2 ran in 0 seconds and produced a passing test. Right? Okay, so that's one test case. Is max 2 correct? Well, you're not really convinced max 2 is correct, right? We only tested it for 0 and 5. Right? So what should you do? Right? You should try more test cases, which begs the question, how many test cases do you need to run? Right? And the answer is, there's no easy answer. Right? You have to look at the method that you're testing, right? And you have to intelligently try to determine what are the best test cases to run to show that your code, to test if your code contains an error, right? And then you sort of have to use your judgment as to determine how many how many cases do you really need to test. So if you go to max 2 and you stare at it for a few seconds, right? You might say, hey, I should really test what happens if that overflows. Right? So in other words, you're going to pick two values of A and B that are relatively large so that the sum overflows. Right? So now you add a second test case. Oh, wrong class. Okay. So to add a second test case, you just make a new test method. So you write at test, right. Public void test 0. I guess we'll call this 2 for now, max 2. Right. If you look online to see what people suggest naming your classes as, there's all your test methods as. Sorry, there's all sorts of advice as to what to name them. Some people will say you should call it max 2 and then 0, 5 to indicate that you're passing in 0 and 5. You might call it max 2, I don't know, just plain old max 2. Here you might call it max 2 overflows, right? Or something like that. There's no standard way of naming your methods. You could just call it test 02 max 2. Right? So we'll just name it that for now. I want it to overflow, so I'm just going to copy the code from my other test. and I want to pick two values that cause the sum to overflow, right? So I can pick any positive value for A, and for B, I'm just going to pick integer max value. Right, so I know that A plus B should overflow, right? And you should also know that when it overflows, the value becomes negative, right? So there's no way this test is going to pass, right? And now when you run that test, right, we see that max 2 fails, right? Got a little blue check mark beside it. Up here it says there's one failure. Down here in the box, it tells you why the test, tells you why JUnit thinks the test failed. Sorry. Very hard. Okay. Oh yeah, right. This stupid thing. So it says here, right? So it's an assertion error has occurred, right? The expected answer was that's integer max value, but the method that max2 actually returned, the value that max2 actually returned was -1, right? And so now you know right away max2 has a bug in it somewhere, right? That sum is overflowing. Okay, now that you've got a test that shows that max2 is failing, you can go back to max2 and try to fix it, right? So how are we going to fix this thing? Well, I know I can't compute the sum like this, right? So I know I can't compute A plus B as an int. I have to compute it as something else. So let's try to fix it. Obviously, the easy way to fix this is just replace it with an if statement, but let's actually try to fix this, right? So long, I'm just going to call it, temp equals. Okay, so I want to do A plus B, like that, right? But that's also going to overflow, right? A and B are both ints, so the sum is computed as an int, overflows, and then you store the overflowed result in a long. So that's no good, right? I have to coerce one of the arguments to long, right? Easiest way to do it is like that, right? So now I've got 0 as a long type, plus A, which is an int, so Java converts the A to long, right? Does the sum, you now have a long plus B, converts B to long, and now the whole sum is computed as a long. Right? So now I can replace A plus B with temp, right? And now the compiler complains, right? Why does it complain? Because temp is long, right? The absolute value is an int. It does the sum as long and stores the result in an int, which fails. Right. So it looks like I have to cast all of this back to int, which isn't what I really want to do either, but let's see what happens if I try this. Sorry. So I'm going to try to solve it this way. Right. Now that I've fixed my code, right, I can go ahead and run my test again. Right. So either go back to your test class, right, or over here, you can right-click and run again. Right? And now it tells you, hey, it's still overflowing. Right? Do I have the same result? Okay, so I'm still getting back -1. So that obviously didn't fix the problem. Right? So what's the correct solution? I have to do everything with long. Right? So back up here, right? Why don't I just do this whole operation as long? Right? Plus math, ABS, AB. Right, and now I want to return, so now I can get rid of this one. And I can return, let me change this back to twice max. So I can do that. What's going on here? Math ABS is not compatible for, the type math is not compatible for, what the heck just happened? Is not applicable for the arguments int. Hang on. Oh yeah, thank you. That would explain it. Okay, good. All right, so we'll try that. It's complaining down here. Twice max is long, right? Long divided by int is long, and I need to return an int. So I have to cast this result to int before I return it. Okay, now it's happy. So let's go back and run our test. Right, so again, just run it from, make sure the test is the class that's in the editor. And if you run it, oh, it's passing now. Right, and that looks great, right? There's still a bug, right? Anybody know what the error is? Anybody? Anybody? I mean, it's staring you right in the face. It's not, okay, so it's not this. What else must it be? Yeah.
Maybe there's an issue converting the long back to the end.
There's no issue. If you work out the math behind all of this, there's no issue there. But that's a good guess. So if it's not line 7, and if it's not that, it must be something wrong here, right? So that difference overflows, right? So that a minus b will be computed using int. So if you pick a large negative value for b, that's going to overflow. How do you show that? You write a test. Right, it's test 3. This one also overflows. Now I'm going to use integer min value. Right, so what's going to happen here when you take 1 minus some very large negative value, right? That's going to overflow to a, what about 1 minus. That's going to overflow to a large positive value, what does that actually do? Well, let's see what it actually does. And it fails, right? So let's see what the answer we got. Okay, so it expected some huge value here, but it ended up with 0 somehow, right? I guess I'll let you puzzle out why we got 0, but you can actually work it out. It's not too hard, right? So now you finally say, okay, so look, this difference here is overflowing, so I have to compute that difference as along as well, right? So again, easy to fix, 0L, right, like that. And now finally, I believe that we've arrived at the correct solution. Oh, still overflowing. 0, that should not overflow. But was 1 now. Well, that's fascinating. 0 as a long plus a minus b. Oh, yeah, sorry, my expected results are wrong. Oh, wait a minute, that means all my tests are wrong. Hang on. Sorry, let's go back and fix everything. That's actually good, so that actually leads to another point. It's very hard to live code, by the way. Okay, so that's still incorrect. Right? And now if we put it back to what I think is the correct answer, I hope this works. Yay, it works. Okay, that's good. So that fixes the problem. Okay, so that was a perfect example of what one of the problems with testing is. Right? So one of the problems with testing is you have to write code to write the test. Right? If you make a mistake in your test code produces the incorrect and possibly confusing result. Right? So that's no good. Right? So you now run into the problem of how do you test the test? Right? And the answer is that you don't. Right? You don't want to go down that rabbit hole. So you have to be very careful when you're writing the actual test code. What other issues are there? Oh, so now that we've fixed our code, are we sure that it's correct? Right? So in other words, are these 3 tests sufficient to prove that the method is in fact correct? Right? The only way you can determine that is by going back and looking at the implementation, right? And intelligently looking at this and determining that yes, in fact, this is now the correct result. Right? And these 3 test cases helped us get to the correct result. Right? Now, if you wanted to absolutely prove only by using testing that max 2 is correct, what would you have to do? Right? You would have to run every possible value of a and b through this method. Right? So there's 2 to the 32 ints, right? And there's 2 int arguments. So there's a total of 2 to the 64 combinations of values that you would have to run through this method, right? Which is a very, very large number. You would never do that, right? And so that's why there's that quote at the beginning of the lecture that says, testing can't prove that your code is correct, right? Right? It's hopelessly inadequate for showing their absence, right? It's because it's impossible to run every possible test case. When you're testing more complicated code, it's actually very hard to figure out what is the expected result in many cases. So if you're writing a function, if you're writing a method that implements some mathematical function, right? How do you actually determine what the correct answer is for that function, right? So for example, if you're writing the method that computes e to the power x, right, where x is some double value, right? How do you independently compute that exponent so that you can test it later on, right? Not clear. So testing is very useful. It's not a magic bullet. Unfortunately, it's the best thing that we've got for the time being. What else do I want to say about testing? This JUnit business. Okay, so in a modern in a modern software development environment, all of these tests would be automated, right? So that means you would keep your source code under what's called revision control. So you'd have some software system that lets you check your code in and out to a repository, right? Something like GitHub, if you know what GitHub is. When you check your code into GitHub, it's possible to ask GitHub to run all of your tests, right, automatically. So when you check code in, it gets tested. If it fails, right, you can ask your repository, you can ask your source revision control system to not accept the commit, right? So it'll kick your code back out and not accept the changes, right? And so you can actually set this up either on GitHub or using whatever other version control system you want to use. There are build systems for Java. So one of them is called Maven that will also do this sort of thing for you, right? So it'll manage all of the software building for you, sort of like Eclipse does, right? So Eclipse, to build my test class, right, I didn't have to compile it or anything. I just pressed the play button. Internally, Eclipse is building your software for you and doing stuff, right? But you can replace the build system that Eclipse uses with a different build system that also automatically runs the tests. So that when you are building your code, the first thing it does is test whether or not the tests have passed, right? If tests haven't passed, you can configure it to not build your code. So a lot of this is done, well, I guess in a professional environment, a lot of this is all done. Testing is part of the process, of the software development process. It's often an automated part of the process. For large bodies of code, it's often the case that there are developers, and then there are separate testers, right? So there are people who have jobs that's primarily testing software. They're not actually writing the actual code, right? They're writing the code that tests the code. And there's many, many other types of testing that are done in a modern software development environment, right? This is just one little glimpse of what's actually done. Okay. So, is it worth, sorry, I just want to quickly check. That's not going to work. All right, so I guess I'll continue for a few minutes and then we'll call it quits. All right, so we're going to go back to implementing classes. And I want to talk about static features. All right, so at the start of the course, all of our methods were static, right? And I told you that anything that's static belongs to the class, right? So to call the static method, you use the name of the class. Right? Now we have objects, so we have non-static methods. To call the non-static method, you use the object reference to call the method. So can you have a class that has both non-static and static methods? The answer is yes. Right? Can you have static and non-static fields? The answer is yes. Right? So you can have static fields. Right? Remember, static fields are just fields that belong to the class. They don't belong to individual objects. What does that mean? There's only one copy of the field, right? The field is associated with the class. If an object accesses the field, it's the exact same field that every other object accesses, right? There's only one copy of the field. Right? So these are also commonly called, in Java, you'll see them called class variables, right? Because it's a variable that belongs to the class, right? Not to an individual object. Okay, so here's a little example of a class that's going to represent a domino, right? If you haven't played Dominoes before, it's a family of games that are played with these tiles, right? Each tile has two faces, right? And it has a number on the faces, right? So this has 4 and a 1, right? In many versions of Dominoes, the idea is to align the tiles so that two ends, so that the matching ends have the same number. In total, there are, I forget how many, but that's all of the domino tiles in a standard, what do they call this? I forget what they call this, in a standard domino set. There's a name for the set. Right? So there's, the values are from 0 to 6. So you can make a little class to represent dominoes. It's pretty easy. Right? So our class domino has has 2 values. Right? Those are just the values of either side of the domino. And now we've got some static fields. Right? So we've got min value and max value. So 0, that's the smallest possible value for a domino side, and 6 is the largest possible value. Right? And so there's an example of when you might include a static field in a class. Right? Here we're making a public, static, and final field. So here we're trying to create a field that represents a constant. Right? So the numbers 0 and 6. Right? These are constants that are meaningful for the game of dominoes. The largest impossible value for a domino. Right. So if you make a domino object, is there a class here? Yes, okay. So in this code here, right, when you make a domino object, right, the first time the Java virtual machine sees the domino class being used, right, the class gets loaded into memory. Right. So our domino class has a field min value and max value, and its values are 0 and 6. Right? We've got 2 separate domino objects here, right? D1 and D2. What's not inside D1 or D2, right? The values, min value, and max value. So these are not part of the individual objects, right? Right? These 2 fields belong to the class because they're static, right? So the objects don't get their own copy of min value and max value. When you're using a static field, you always access it using the name of the class. Right? So for example, if you wanted to print out the minimum value of a domino, you would write system.out.println domino.minValue. Unfortunately, the language says it's legal, but considered bad form to access a public static field using an object reference. That public doesn't need to be there. Right? So it's legal to make a domino object and then write d.minValue. You should not do that. Right? So the reason you shouldn't do this is because when another Java programmer comes along and looks at your code, right, they see object reference, dot something. So the other programmer is going to think that min value is a non-static field. Right? So in other words, they're going to think every domino has its own min value field. Right? Even though in this case, that's not the case. Right? It's not until they go and actually look at the documentation for the domino class do they realize that this is in fact a static field. Right? So when you access a static field, use the name of the class. Right? Why do you do that? It's so that your code communicates clearly to other Java programmers that the field is static and not non-static. Okay, so final, when you mark a field as being final, that means you can only assign it a value once. Right? So when I write min value equals something, that's the last time I can write that. Right? So public static final fields, they're intended to be constant values, right? So values that never change. Typically, if it's public, you want other people to know about them. So that means that that field is a meaningful part of the abstraction provided by the class. Right? So in this case, the numbers 0 and 6 are meaningful to whoever's using a domino. Right? They represent the minimum and maximum value that a domino can have. If you have a field whose type is primitive, right, and it's marked final, then it really is a constant. Right? If someone tries to change min value, right, by writing domino.minValue equals something, the compiler won't compile it. Right? The compiler will indicate min value is final and already assigned a value. Okay, if you have an immutable, if you have a final field whose type is a reference type, but it's also immutable, right, then this object is also a constant. Right? So, or sorry, X also refers to a constant object, is the better way to put it. Right? So if I have a string that's marked final, and I assign it a reference to an object, right? Then there's no way that I can assign nothing to hide.x a different reference, right? So I can't assign a different string to that variable, to that field, right? Again, the compiler will say you've got a final field, you can't assign it a value anymore, right? So string's immutable. It has no methods that can change its contents, right? So the string peekaboo is always the string peekaboo. X is marked final, so I can't make x refer to anything else, right? Those two things put together means that x is a constant, right? It always refers to the string peekaboo. If you have a reference type field that's mutable, it's not constant, right? So here's my class, really nothing to hide. Here I've got a list, and it's called empty to indicate that this is the empty list. Surprisingly, this is sometimes useful, although you shouldn't do it this way, right? So whoever created this class is saying, hey, look, this field called empty is an empty list, right? If you ever need an empty list, use this list. What's the problem? You can call a method belonging to the list that changes the list, right? So now your empty list is no longer empty. It now contains the string oops, right? And now you've got a problem, right? So in this case, the list empty is not logically constant, right? Its state can change. So if you need a constant, right, don't make it a mutable type like list, right? Make sure that it's some sort of immutable type like string. Okay, so avoid using mutable types as public constants. They're not constant, right? Their state can change, and it can be changed by anyone that has access to the field. Okay, that's a good place to stop. We'll talk about static methods in the next class and why you might want to put them in a regular class.